So we are going to begin vocabulary. So you will find this blank vocabulary sheet in Google Classroom. So we're going to add 5 vocabs to our first sheet and make sure you plug that in. Now, the corner here is supposed to say formula. So you can add that. And then this one is left for any sort of like extra pieces, and if a graph is acceptable, we'll put a graph over there. Okay, so the definition is the rate of change of y versus x. You can also call that the slope of a line. So as far as formulas go, we're going to use the change in y or delta y over delta x. Okay. We can rearrange that for some contexts where delta y equals the slope times delta x. Back over where it says definition, we could also write in words change in y divided by the change in x. So I would include more of the words in that spot. As far as examples go, let's say that we want to find the rate of change, the constant rate of change for the points 2, 1 and 3, 4. So we can just do the difference of the y's. So if we call this x1, y1, and this one x2, y2, would be 4 minus 1. The difference of the x's would be 3 minus 2, or 3 over 1, or 3. That's one way to do that. Another way that this is helpful is if we had the, let's say that we were given that delta x was 5 and delta y was 7, and they wanted us to find the constant rate of change, then we would just do delta y divided by delta x, or 7 over 5. So now let's make a little graphical interpretation. So I just kind of made a line. I'm going to pick 2 points. I'm going to show my delta y, my delta x, and my slope is delta y over delta x. So that's our first definition about constant rate of change. So all of these definitions that we do will include some examples, formulas, all that stuff. So it will be helpful as a study guide. Our second definition, we are going to do the point slope formula. Of the line. So over in the formula spot, let's write that formula down. So y minus y1 equals m times x minus x1, when m is the slope and x1, y1 is the point. So that's the formula I'm talking about. It is the way to find a formula or equation of a line if we know a point and the slope, or the constant rate of change. Okay, so a graphical interpretation, you know, we would have to know a point, and then we would go the slope delta y over delta x. There's not much graphically because this is an algebraic technique that we could use. But as long as we know an x1, y1, and a slope, we can find the equation of the line using this technique. So let's say we know our slope is 4, and we have some point. Let's say it goes through the point 3, 7. So we can just plop that into the formula. Y minus 7 equals our slope times x minus 3. And then I'm not going to rearrange it. Hopefully you know how to do that. You would distribute and then add 7. But as long as you know how to put it into the formula, then the rest should be good. Our third definition is going to be average rate of change. Now, a constant rate of change refers to the slope of a linear equation. The average rate of change is the slope between any 2 points on a curve. Okay, so it's referring to the slope of a secant line. Secant line just connects any 2 points on a curve. So I'm going to show you an example first. So all you need to do for a graphic example first, all you got to do for a graphic example, make some kind of function that's a curve of some sort. Doesn't matter what it looks like really, as long as it's a function. Take 2 points. It can be anywhere, doesn't matter. Connect them with a line, and you would want to find the slope of that line between those 2 points. So we have to go, so if we go to the formula spot, from x1, y1 to x2, y2, we're going to connect it, and we have to use the change in y over the change in x. So same technique as slope, but these are just 2 random points on the graph. So sometimes we will say on the interval from our first point to our second point. And that's something we'll discuss more as we go. So an example, we're just going to use the graph. Let's just make up points. Let's say that's 1, 1. And let's say this is 4, 3. So our average rate of change would be y2 minus y1 over x2 minus x1, slope. So in this case, if we use 1, 1 and 4, 3, that would be 3 minus 1 over 4 minus 1, or 2 over 3. So average rate of change is just the slope, but it is the slope between any 2 points connected on a curve, the line that is created. That's the slope you're looking for. Fourth one in this particular set is about quadratics. So a quadratic is, let's just, for definition, let's just say a parabola. And for formulas, it is y equals ax squared plus bx plus c, or y equals a times x minus h squared plus k. Either of those forms is acceptable for a parabolic function. Some other formulas to note is the vertex as x is always negative b over 2a, or the h, if you're looking at that version, that does say h. The negative b over 2a comes from these values. It's the opposite of b over 2a's. And then the vertex, you just plug that h in and you can find the k. And then for this formula, it does just appear, which is really good about that formula. If your a is positive, your parabola will point up. If your a is negative, your parabola will point down. You know, let's bring those where the graphical interpretation is. I'm going to make it bigger for you here. So if the a is positive, it'll point up. If the a is negative, it'll point down. For the purposes of the video, we're going to come back to examples later on. All I need to see are those three things at this time. And then our last thing on this particular set, so we'll call this vocab 1, is about the distance formula. So the definition, it's just the measurable length between two locations. Let's jump to the formula spot. Distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. You can also call that delta x squared plus delta y squared. You can also say this is related to the Pythagorean theorem. Which is a squared plus b squared equals c squared. So let's go up to our picture. And let's go to the point 1, 1 and 4, 2. And this is our distance. And then in the example spot, let's just find the distance. So find the distance between 1, 1 and 4, 2. So we're going to label the points. I like to go from left to right, making our leftmost point the x1, y1, and our rightmost point x2, y2. It's not really important right now, but it's helpful for thinking of domain and other things. So let's just get in that habit. So our distance, if we utilize the formula we see here, is going to be 4 minus 1 squared plus 2 minus 1 squared. Now, follow order of operations. So we are going to do inside the parentheses. We'll get 3 squared and 1 squared. Then we'll do the squared. That's 4 plus 1. It is not. I'm sorry. 3 squared is 9. 9 plus 1 is 10. So that's the square root of 10. Now, since that's not a perfect square root, just reduce it as much as you can. Can't do anything else. Leave it. That's the distance between those 2 points. So that is a little bit about distance and the other concepts we saw here. Please turn this in to the vocab 1 spot. Keep this paper in Notability. We're going to continue to add on to it. Okay, so there you go.